So we're here at the example table, and in this video we're going to sketch the graph of f of x equals natural log of x plus 1 plus 1. So if we're going to sketch something like this, it's usually a good idea to start with the graph of something simple. And here we want to start with the graph of the natural log of x. So this I hope is familiar, looks like this, right? Crosses the x-axis at x equals 1 and has a vertical asymptote along the y-axis. So now we have these two plus 1's to deal with. Let's deal with the plus 1 on the inside first, because this is usually the one that's a little bit trickier. So you could just memorize that when you add something on the inside, you shift to the left by whatever that amount is. If you subtract something, you shift to the right by whatever that amount is. But I try not to memorize that because I'm liable to memorize the wrong thing or just forget it or who knows what. So I like to figure it out each time I need it. And let's do the long way to figure it out. We'll draw a table. You don't need to draw the table each time, but it can help. So natural log of x in the left column, natural log of x plus 1 in the right column. So let's write down three values here. Natural log of 1, natural log of 2, and natural log of 3. I don't care what these are equal to right now. They're just some numbers, and they come from plugging in x equals 1, x equals 2, and x equals 3. So the question is, what do I need to plug in for x on the right-hand side to get these same values? So in the first row, if I want to get a 1 inside here, x needs to be 0. So this is natural log of 0 plus 1. If I want a 2 on the inside, I need to plug in x equals 1. That gives us natural log of 1 plus 1. And if I want a 3 on the inside, I need to plug in x equals 2, because that gives us 2 plus 1. So when you plug in 0 for x, it behaves like natural log of x does at 1. If I plug in 1, it behaves like natural log of x at 2. Plug in 2, behaves like natural log of x at 3. So this one is just, everything happens to this function a little bit earlier, exactly 1 unit earlier. It's shifted over to the left, right? Natural log of 1 is 0. Natural log, when we plug in x equals 0, we get natural log of 1, which is 0. So you can see this point in particular is going to be shifted over right here. So let's sketch this now. One thing that's easy to forget is vertical asymptote. Vertical asymptote is also shifted. So now we have to draw explicitly this dotted line. And this dotted line, this is x equals 0. Shifted over, becomes x equals negative 1. And now we sketch the graph. Remember this point, 1, 0, got shifted over to the left by 1. So this graph now passes through the origin. The second thing that we have to do is add the plus 1 on the outside. That's a little bit easier. Let's start it on the next sheet of paper. So, just to re-sketch, natural log of x plus 1 looks like this. I won't relabel. Looks like this, passes through the origin. Now, we want to graph natural log of x plus 1 plus 1. So remember, a graph represents a function's value using the y-axis. So if you add plus 1 to this function here, all you're doing is shifting the whole graph up by 1. Right? So that's why this one's a little bit easier than, this plus 1 is a little bit easier than this plus 1 on the inside. So to graph this thing, we take the graph of natural log of x plus 1 and shift it up by 1. Now, vertical asymptote, shift it up, doesn't change the position. So we still have a vertical asymptote at x equals negative 1. But now we're shifting up by 1. So take a look at the origin. This point on the graph that now passes through the origin is going to be shifted up by 1. So it's going to pass, let's say, through here. One tip when you're graphing, draw the line before you draw the point. If you draw the point first, you might miss it when you try to draw the line. Just a little hint, I've done that 1,000 times. So we have this point here, and this is now 0, 1. The only thing left to do, if anything, is to find the x-intercept. Sometimes you might not need to find that, depends on what you're being asked. Here, let's find it just to be thorough. So finding the x-intercept, this is the value of x for which y is 0. Because if you cross the x-axis, y is 0. So we want to write down natural log of x plus 1 equals 0 and solve for x. So let's move the 1, this plus 1 on the outside to the other side. We get natural log of x plus 1 equals negative 1. Now, remember that natural log of x and e to the x are inverse functions. So if we want to cancel this natural log, we take e and raise it to this side, to whatever we see over here, and we take e and raise it to whatever we see on the right-hand side. E to the natural log of x plus 1 leaves us with x plus 1. And then on the right-hand side, we get e to the negative 1. And so finally, x, e to the negative 1, remember, is 1 over e. This is 1 over e minus 1. So the finishing touch on the graph is to label this point, and it's 1 over e minus 1, comma 0. Now we're done, but it's worth checking. It's worth taking a look at this to make sure that this value here actually makes sense. We know, based on the process that we went through to produce this graph, that this point here, this x-intercept, must be on the left of the y-axis, right? X must be a negative number. It wouldn't make sense if this point were over here, right? Or over here, or over here. So this must be a negative number. Does this make sense? If we got a positive number here, then we know we did something wrong. So that at very least, it's a good idea to make sure that we got a negative number. Well, for this to be negative, we want 1 over e to be less than 1. So let's start with something that we know. We know that e is greater than 2, right? E is 2 point something, but it's greater than 2. Now, if we take 1 over each side, we have 1 over e and 1 over 2. When we do that, we reverse the direction of the inequality. Right? So 1 over e is strictly less than 1/2. And of course, this is strictly less than 1, which means that 1 over e minus 1 is less than 0. Right? So this is something that's worth checking if you have time, and it's certainly worth checking on homework to make sure that your answer makes sense. And this is the graph.